Okay, we're going to do the answers to page 104, 105. So here it's asking us this triangular distribution, asking us to write down the parameters. So hopefully you watched the video from yesterday and looked at your notes. So A is here, and B is here, and C is the peak, which is here at 3. So my A is 1, my B is 6, and my C is 3. People, make sure you don't go A, B, C. It's always A is the beginning point, B is the ending point, and C is the peak. Now it says calculate the maximum height, so I'm calculating the height here. Now you can see it off this graph, but when you do it in your books, it's not going to be that easy to do, or in your exam, just to see it off the graph. So you need to do a calculation. Now this is a triangle, so we know the area is equal to base times height, half base times height, or base times height over 2. Area of a distribution, everything underneath is going to equal to 1. So 1 equals 5, my base, from 6 to 1, that's 5, times my height, which I don't know, over 2. Rearrange this, it's divided by 2, get it out the side here, times by 2, so we're going to have 2 equals 5h, and then this is 5 times h. To get h by itself, I need to divide by 5, so h equals 2 over 5, which is equal to 0.4. So now we've shown that the height is 0.4 when this is 3. Next one says in order to calculate the probability for x being more than 5, so I'm going to draw that on here again. 5 is here. So I'm trying to work out the probability that x is more than 5. So shade it in, that's the bit I'm trying to work out. I'm trying to show that it's 0.13 recurring. So we need our formula. Now the formula will be on your formula sheet. My formula when it's above the mode is h equals, so that's my height, or f of x, equals 2 times b minus x. Now I don't remember this at all, over b minus a over b minus c. It's been a few years since I did triangular distribution last, so it's not a formula I remember, but it's on a formula sheet, so it's okay. So I'm going to substitute everything in. So my f of 5, which is going to be my height, is going to equal 2. So I've substituted everything in. Everything should be easy because you have your a, b, and c here. The only thing is f of 5 is what you're working out, so that's your x. X is the number you're trying to work out. When I simplify that, I get 2 times 1 over 5 times 3, which is 2 over 15, which is 0.13. Next one says to draw lines to show f of x equals 0.13 on the graph above. So the only thing I'm going to add there that I haven't already done is a little dotted line across here. And you can label it 0.13 recurring. So now we're actually going to work out the probability of this. We've worked out the height there, but we don't know the probability yet. Now remember, probability is the area under the distribution, and I have a triangle, so area is equal to base times height over 2. So the probability that x is greater than 5 is going to equal my base. Now if I go up, it's really annoying that I have to keep zooming out. My base here goes from 5 to 6, so my base is 1. So it's 1 times, now I worked out my height was 0.13 recurring. I'm going to leave it as a fraction because it's easier to deal with. You can leave it as fractions. Don't know why that book's so obsessed with decimals. And then over 2. So that's half of 2/15, which is 1 over 15, which equals 0.06. Okay. If you're not confident with doing any of that, in your head, use your calculator. Okay, now I'm going to show that f of 2.5 is equal to 0.3. So 2.5 is here. So I'm trying to work out the height there. Now the formula is slightly different in the lower half underneath the mode. So I'll copy it again because I don't remember it off by heart. So f of x, which represents the height, is equal to 2 bracket x minus a over b minus a over c minus a. After doing it a few times, you might start remembering it. Okay, I'm going to substitute everything in. I know that x is 2.5 because that's what I'm trying to work out. So I've substituted everything in into this formula. Only thing that's tricky is knowing that the x is 2.5, the x is this value here. Otherwise, a and b and c, you know from the beginning. Substitute it in and I get 2 times 1.5 over 5 times 2, which equals, I'll do it over here, equals 3 over 10, which hopefully you do know is the same as 0.3. No calculator needed to work that one out. Okay, finally, find the probability that x lies between 2.5 and 3. Okay, so if we're trying to work out the probability that it's between 2.5 and 3, we have now created another shape. It is a trapezium. So if we flipped it around, it would look like this over here. So the height here is 0.3. So I've put that here like this. The height here is 0.4, so I put it along here like this. And the distance between 2.5 and 3 is 0.5. So I've created a trapezium. Now, if you remember from Year 9 Maths, the area of a trapezium is the sum of the two parallel sides divided by 2, or half the sum of the parallel sides times the height. Now, I've just written top and bottom because normally in trapezium formula we write A and B, and we don't want to get confused with A and B because we have a different A and B. So it's the top and the bottom divided by 2 times h. So to work out the probability that it's, question's down there, but I'm going to do it here. Probably that 2.5 x 3, the probability that's between 2.5 and 3 is going to be the area of this trapezium. So that is 0.4 plus 0.3 over 2 times 0.5. So that is 1, 0. Also 0.35. I did this in my head before. So it's half of 0.35, which is 0.175. Okay. So I'm going to re-put that where it belongs. So in that question, we still know our A is 1, our B was 6, our C was 3. X1 was the height of one of the values, and X2 was the height of the other one. Created a trapezium out of that, and I found that the probability that 2.5 x 3 was 0.175.